I'm pleased to introduce the leader of our AI workshop, Aditya Vetukuri. Aditya Vetukuri graduated from JNTU Hyderabad with a bachelor's degree in computer science. He's currently studying at George Mason as a graduate student, where he's specializing in machine learning.
Hi everyone. Firstly, I would like to thank my professor, Kamaljit Sangera, for this wonderful opportunity to come here and share some knowledge with you guys. I know all of you are high school students, so I thought I didn't personally learn machine learning from high school, so I started it learning from my bachelor's degree. So I really think it's cool if you started off early because there are some huge insights which you can dig deep in this industry. So I just thought I would give you a brief introduction to machine learning. Then I thought I'll share some resources at the end personally for you, which would help you learn machine learning better than I learned. So currently I'm doing my master's here at Mason in the concentration of machine learning. So I thought it would be a great opportunity to teach a small presentation on this. And thank you for showing up and being patient and staying for the workshop. So let's just start the presentation. Can anyone help me how to create a poll in this Zoom meeting?
I have a poll. It's ready when
It's ready.
you want me to launch it.
Oh yeah, please go ahead and post the poll if you can. Yeah, feel free to answer this poll. It will just help me to go with the pace with the presentation. I can't see the results. I think.
Here, I can read them out to you. So, 38% of people have heard about ML. 18% of people have studied ML but not really implemented it. 23% have studied ML and implemented it, and 22% of people have not heard what ML is.
Yeah, that's good. Most of you have very good insights about it. That's cool. So let me go ahead and start the presentation. So we'll be briefing about machine learning, a few basic concepts of how machine learning works. And so here are the table of contents. We'll go to the introduction, what is machine learning, and we'll later on have a quick history of machine learning. And we'll find out what's the difference between a traditional programming language and how the machine learning works. And we'll see how the structure of machine learning is, and we'll go what are the types of learning, and we'll know what are the applications of machine learning. In the end, we'll do a small exercise, and if I guess if we have time, we'll build a small machine learning app. It's just a web app. You don't need to code a lot. It's just a machine learning app with a backend of IBM, which provides you inbuilt machine learning services. So yeah, what is machine learning? So machine learning algorithms
Yeah,
enable.
we can't see the presentation. I think you have to screen share it.
Oh, I think I did. Okay. Oh, can you see the presentation now?
Yeah.
Oh, I'm so sorry. I'm so sorry for that. So here is the table of contents. We'll go through the introduction of machine learning, and we'll study what the history of machine learning is. and we'll see what is the difference between the traditional programming language and machine learning. So we'll see the structure of machine learning and what are the types of learning and applications of machine learning. And we'll do a small exercise at the end, which is quite interesting, and we'll build a small machine learning app. So what is machine learning? So machine learning algorithms enables computers to learn from the data which we have, and they improve themselves whenever without being explicitly programmed. In the sense, we give the data to the model. The model can be anything. It can be a file or something. We give the data to the model, and we run the model and let itself train on the training data which we have. We don't have to do anything to it. Once we run the model, it keeps improving itself without being explicitly programmed. That is one good thing about machine learning. So machine learning is a category of algorithm that allows software applications to become more accurate in predicting outcomes without being explicitly programmed, which I said. So to be precise, um, you train the model on some certain amount of input data, and you apply statistical analysis to it and predict the output whenever you see a new data. So whenever new data becomes available, we need to make a model in such a way that it predicts the correct output. So this is a quick history of machine learning. So computers were like first electronic numerical integrator and computer was first introduced in 1940s. So at the time, the computer was just being used for human numerical computation capabilities. So at first, people thought that it was only for calculation purposes. It's not mostly for learning. It's not something related to learning, but people were wrong from the beginning. The idea was to build machines to emulate human thinking and human learning. So in 1950s, they introduced a first computer program which was able to beat checkers world champion. I think you all know the game checkers, right? So this program also helped the checkers players improve their skills. Around the same time, Frank Rosenblatt invented the perceptron. Perceptron is one kind of deep learning network layer. So he built that classifier. When it combined with large numbers, it was really a powerful monster. So but later on, when the community started to apply deep learning algorithms on certain problems, they were facing a lot of difficulties. uh, but thanks to statistics in 1990s, so IBM introduced a system called Deep Blue system, which was able to beat the world champion Gary Kasparov. Gary Kasparov. So Gary Kasparov couldn't take it, and he accused IBM of cheating. That he couldn't see the previous games of IBM Deep Blue system, which was playing chess. But on the other hand, the IBM Deep Blue system program could read all the moves which were performed by Gary. So he really thought it was unfair because the system could read all his moves, but he couldn't even look at what even one move of how the Deep Blue system works. So that was a history of machine learning. Sorry for too much theory in that slide. Uh, so, so this is traditional programming language. So whatever it might be C programming language or Java programming language. So you have an input and you have a desired output, right? So in order to get the desired output, you write a program. Suppose if your output is print the sum of the numbers in the array, then you write a program to get that desired output. That's your traditional programming language. But in machine learning, you have the input and you also have the output. For some of the machine learning models, I'm not generalizing with all of them, but most of the machine learning models, you have the input, you have the output, and you build a program uh, based on the input and output. So whenever you get a new input, you should be able to predict the output based on the program. So it's more like gardening. So the seeds at the base level are your algorithms, and the data are the nutrients for your plants, and you are the gardener, which you have to take care of the plants which are essentially the programs. So here is the structure of machine learning model. So at the ground base, you have the data. The data can be raw text, it can be music, it can be sounds, it can be numbers, etc. So a lot of your Python programming or any programming language, it works till data preprocessing and dimensionality reduction. Beyond this, everything is basically statistics. So in the first part, we have the data. So we need to pre-process the data, because in real world applications, there are a lot of noisy data. Uh, there are a lot of irrelevant text which we need to remove in order to send the model, because it might damage our model optimal accuracy. So there is this thing called dimensionality reduction. What In this example, you'll get to know it better. So just consider these two are two reviews by users. So the first one is Avengers is a great movie, and the second one is Avengers: The Endgame was disappointing. So here we can predict the sentiment of the user just by knowing the subject Avengers and features like great, movie, disappointing, and so on. But we don't really need certain features like is, a, was, and the in this particular example. Uh, by reducing the features, we can improve the model execution time. So the execution time is one of the really important aspects for machine learning models. So we reduce the dimensions, we reduce the features from the data, and we send it to the model. So the model trains on this data, and later we have parameter tuning. It's just you uh, optimize the model parameters and look for the model's accuracy. You tweak the parameters and try to improve your model's accuracy. And later you can test your model on real world applications. Yeah. So what is a machine learning model? So a machine learning model is nothing but a file that has been trained to recognize certain type of patterns, certain type of outputs. So you can train your model over a set of data, providing it an algorithm. Algorithm is just a sequence of steps that you can reason that certain amount of input data is giving the certain amount of output. So once you have trained the model, you can use this reason. You can use the things which you've already built, like these inputs are giving these outputs. So hey, what happens when the new unknown label comes? So you go through your previous input and output pairs, and you try to predict the data. So here's an example. Think of an application that recognizes users' emotions based on their facial expressions. So you can train your model, providing it images of faces that are each tagged with certain emotion, and then you can use the model whenever you say a new user's emotion. So in machine learning, you have mainly three types of learning. One is supervised learning, and the other one is unsupervised learning, and we have reinforcement learning. So here's a small joke of the three, which shows the differences between them. So in supervised learning, you have the training data and you have testing data. In the sense, you have 1 + 1, you have the desired output is also 2. So they have training data and they have output data. So whenever new data comes in, they have to predict it. But in unsupervised learning, they don't give you answers. You just have the questions, and you need to build your model and predict outputs while you are executing the current model. And whereas you consider reinforcement learning, you don't have your input and you don't have anything. You have to make your own rules and build your model based on the rules. So supervised learning. Supervised learning is a type of machine learning algorithm. As I said, you have the input output pairs in the training data to map the input from test data to their respective output. So consider an example that you'll get to know about this later in the example. Uh, So an unsupervised learning is a type of machine learning that uses inferences drawn about a data set that is devoid of labels. As I said, you don't have the labels. You need to uh, divide a data set into labels based on your model. So the most common type of unsupervised learning model is clustering. So this is an example of supervised learning. So you have a data set which contains spam mails and which are not spam. So when you have a spam mail from your inbox, you can basically predict with your eyes that it's a spam mail. It has those particular banners. It has those particular objects. It has that greedy. What do you call greedy offers which provide us to clickbait, and so you extract these features from these spam mails and give it to the machine, saying that, hey, whenever certain uh, mails contain these type of text, then that's a spam. And whenever the email text is clean, you say the computer that it's not a spam. So the computer learns these inputs about spams and not spam, and whenever a new mail comes and pops out, and the system predicts that it's a spam or not spam. Or else consider a simple example of two ships, ship A and ship B. And in ship A, you have crates. You have some crates which have labels, and you as a person note down these labels that for certain amount of dimensions and for certain amount of color and certain amount of weight, the label is this. You note down this input features, and you have a ship B which have crates, but you don't have any labels for them. So you note down these features, and then you go back to the ship B, and you need to predict these labels based on the input data. That is as simple as supervised learning. You have training data and testing data, and you have to predict the data when you see a new label. But in unsupervised learning, you only think as it as an example that you only have a ship that doesn't have any labels for that. You don't have any output labels. So consider this example. Uh, these are our input images, and we don't have any labels for them. So when we go on building the model, we divide these images based on their features. Suppose these images have uh, as they are ducks, their shape of their noses and the shape of their body are same. So we keep we keep differentiating the data set based on their features and the difference between the features. So as we keep clustering the data keeps on becoming more sparse and sparse, and we divide each of the data into clusters. So as I said, clustering is one of the major example for unsupervised learning. So reinforcement learning. So reinforcement learning is very similar to someone who trains a dog. So you ask your dog to perform a task like go get a ball or something. So when it gets the ball, you give him a treat. All right, you give him a treat. So reinforcement learning works exactly the same. So you have a model where you have an agent. The agent is your dog. So you build a path in the model, and whenever it goes to the right path, you treat it, and whenever it goes into a wrong path, you give it a penalty. So the model has its own book, it has its own rules, it has its own set of rules, and whenever it goes by the right rules, you give it a treat, and whenever it tries to deviate from its path, you try to give it a penalty. So the model learns from this penalties and treats which you give to it, and this approach is followed by reinforcement learning. So this is a good example to understand reinforcement learning. So this is the agent we are talking about. The agent, whenever it tried to reach environment fire, so whenever when it touched it, so we reduce the points for it. So the model learns that, oh, this is a wrong path to reach. What's the right path which I have to follow? So then it goes to the next, it will try to avoid it. So the next time when it goes to the path which has water, you give it a treat. So the model knows that this is the right path and the following data should follow this path in order to build the right model. So here's some applications of machine learning. So machine learning is used in web. So whenever you type something, there are so many recommendations which you get that is built on recommendation systems. And machine learning is used in computational biology, even the corona vaccine, which students are trying to build. There's a lot of machine learning models which are going in and trying to use this data as potential inputs. And finance, there are finance is now having so much of scope in machine learning. And e-commerce, as you know, Amazon is leading the market with some really good machine learning models. Machine learning is used in space exploration. We have it in robotics, information extraction, which is data mining. So it's used in that, and we have social networks with Facebook with such an very good research in machine learning. So as you guys are a lot of high school students, when you come to the machine learning field, everything looks like unfamiliar to you. But as soon as we understand machine learning, trust me, it's a really good field to study upon. Once you understand how it works, and once you understand how your data is getting manipulated and how your data is getting filtered, you'll have really good fun time doing machine learning. So that's about the slide, and this is a small exercise which I want you guys to try it out with me. So suppose you have two friends, Tony Stark and Steve Rogers. So Tony sends you 200 daily WhatsApp messages, and 90% of those are non-important. So these are like spam messages. And Steve sends you 10 messages, and 90% of them are important messages. So on a Monday, you pull up and you see an important message turned up on your phone, and who would have most likely sent you that message, Tony or Steve? Uh, Feel free to use the chat for this. Like, who do you think? What is the most common answer you think? So most of you would think Steve sends you important messages, so it must be from Steve, would be general perception, right? So total messages received last week would be 200 into 7, because daily Tony sends you 200 messages and Steve sends you 10 into 7 messages. So that will be 200 into 7 plus 10 into 7, that will be 1470. And you have total messages sent by Tony, which is 200 into 7, that is 1400. And total messages sent by Steve are 10 into 7, which is 70. And total messages, important messages from Tony will be 10% of 1400, which is 140. And total important messages from Steve would be 90% of 70, which is 63. So total important messages equals to 140 plus 63 equals to 203. That are the total important messages. And now let's calculate the probability of important messages from Tony, which is 140 important messages out of 203, which is 69%. That means Tony has a 69% chance that he might send you the important message on that particular day. And probability of important messages from Steve is 31%. So it's now we can see that our guess was wrong, and we just found out that Tony was the guy who tried to give who's giving important messages from us. So we just built a Bayes theorem. So Bayes theorem usually works. It's a probability model. It's one of the important machine learning models which we have. I guess all of you guys know what Bayes theorem is, and it's one of the pillars of machine learning. So yeah, we just built a machine learning model in a pseudocode format. That's about it. So I'll go on. I think we have time. Yeah. So there is this website, Machine Learning for Kids. If you guys are like really new to machine learning, then this is the right site for you. Or there are a lot of more websites which you can work on. So this is a website which you have there, which they provide, and the backend to this website is IBM. IBM produces a lot of inbuilt machine learning services. So I'll just go through the project which I did yesterday. Just a second. Just a second. Just give me a second. You can go ahead and ask some questions meanwhile, which I'll try to answer. Yeah, let me share my screen.
Hi, Aditya. We have one question from the audience. How should we get into machine learning as high schoolers? What would you recommend?
Yeah, so the first thing would be I got a lot of questions from like I've read posts on blogs and all. People are really they get really confused whether they should enter to machine learning or not, because they have this thing that we need to be like really good in math. Like we need to have a strong math background to enter into machine learning. I would say you don't need as much knowledge as a maths degree, but you need a basic foundation of math, like how probability works, how statistics works. You need to have really good grip on statistics. So before diving into machine learning courses or machine learning models, I would highly recommend like get your basics right, like get good at math, get good at statistics and probability, not too much, but cover the basic concepts. then you'll really you really won't have a tough time studying machine learning, because it's once after as I said, once after you pre-process the data, like you clean the data and you try to fit your model, the rest is all math. The rest is all math, trust me. So this is a machine learning, just an application. So what I did was, it's nothing, just
Sorry, I think you can only see your top browser bar right now. I think you might need to re-screen share.
okay. So you can see it now?
Yeah, we can see it.
Yeah, thank you. Thank you, Kavya. So I gave two labels for the text. This is kind things and mean things. So what our project is, we have an emoji. Just a second. I don't know why it's not showing up.
Aditya,
Yeah.
I think what we can do is if you could share this link in the chat, I think everybody at home can open it on their own browser, because we have the next panel starting in 8 minutes, and we have a couple of questions from the audience, which I think
Okay. Okay. Then, okay. I'll just share the link.
All right.
I mean, I created an application, but I don't know why it's not opening. Yeah. Yeah. So what's the next question which we have?
Yeah, so one question that we have is, when did you get your own interest in, when did you kind of start to develop an interest in machine learning?
Yeah, so back in my bachelor's, where I was working in an internship, so I was mostly interested in software development. I was really busy in working small scale Java applications and all. I was not really interested in machine learning, but we have to do a. But back in my bachelor's, we had to do a final project which we had. So my final project was a multi-object detector from your laptop screen. So it could detect up to 36 objects at one glance. So at one glance from your laptop, you could detect multiple objects from multiple objects. So at that time, I was really doing a lot of research on machine learning on OpenCV and a lot more. So that time, I got enthralled by the things which were working in ML, and that was the time when I thought to do my master's in this field.
One more question that we have in the chat. What programming language do you suggest that people use when they're trying to learn machine learning or trying to develop machine learning applications?
Yeah, so I would say Python, because Python is very user friendly. You could also try R, but I would personally, from my experience, I would recommend Python, because Python has a lot of inbuilt modules, a lot of libraries which you can try, and it's very user friendly, unlike the other programming languages. So, yeah.
All right. Well, thank you so much, Aditya. And that was a great workshop, and I'm sure everybody learned a lot about it. Machine learning is kind of one of those fields that is still being defined. So there's a lot of questions that people have, and I think your workshop did a great job in kind of explaining those.
Thank you so much, Bhavjit, for this opportunity to come here and show up and share some small knowledge which I have.
Thank you.